Good day, Algebra 2. This video is made in preparation for Monday, August 23rd. I'm out as of that Monday, or today, I guess, by the time you're watching it. And I'm going to give you the video notes for our next topic. You should be getting a paper in class. It's going to be double-sided. There's 4 examples. 3 of them we're going to actually do. The third one is being skipped, and you'll see in the video when I explain that in a little bit. But it has to do with graphing inverse functions. Last week we talked about finding and deriving the inverse function and, switching the x and the y around and solving for y and all that kind of stuff. Now we're going to look at the graphs and what this visually looks like, geometrically speaking. So I had to do my lesson digitally because my document camera that I have here isn't working. So instead of just fooling myself doing everything by hand like I would normally, I had to digitize everything. So you're going to do everything by hand, but I'm going to show you the steps in the work and explain everything in the meantime. There will be some graphing involved. I was kind of hesitant about making you guys do everything by hand, but I decided, technology exists for a reason. So I want you guys to use Desmos to get your graphs and to get your tables for today's assignment. It'll make your life a lot easier. Unless you want to challenge yourself and do all the math by hand, but that actually leaves room for possible error. So just a heads up, I would just use the Desmos and it's just a lot faster. All right, so let's get right into it. So today it says graphing inverse functions. We're going to graph the following functions and their inverses. And we're going to graph the original one in green and then ultimately graph the inverse in red. And then we're going to state the domain and range. Domain and range I'm going to hold back on until I get back into class. So the sections that say D and R on your notes, so just leave them blank and I'll discuss it further when I get back on Tuesday. So we have 3 parts to each one of these problems. We have a function given to us in function notation form, f of x, and we're asked to find the function and its inverse. So we'll do the math like we did last week first in this first column. Then we have to make a table of values in which we'll use Desmos at that point to get our values. And then we're going to have to graph, we'll get the inverse values, and then we're going to graph both resulting graphs and see how they compare to each other. And I think you're going to find something very interesting by the end of this. So let's just get right into it. So number 1, we have f of x equals 3x minus 5. First, to find the inverse, we first have to switch out the f of x notation to y equals. So now we have y equals 3x minus 5. Based on last week's notes, our next step is to switch all the x's and the y's around. So now I get x equals y, x equals 3y minus 5. There we go. That makes a little more sense. And then I'm going to go ahead and solve for y. I'll do that, and I'll kind of show my extra steps, I guess, over here with a different color maybe. Yeah, so I'll go ahead and I'm going to add 5 to both sides of my equation. So I'm going to add 5 to the right and as well as 5 to the left. Whoops. Let me get my color changed again. Actually, I can just copy paste this. And I'll do the same thing to this side. There we go. So but now my equation, when I come down a line, I'll go back to using black now. This is going to be interesting. Is now x plus 5 equals 3y. Now I'm going to go ahead and divide everything by 3. So I'll divide the right side by 3. Oops. And I'll divide the left side. In order to show the left side being divided by 3, I'm going to put it in parentheses and then show division this way. It's kind of hard to get the fraction bar on here doing it at this speed. So I'm going to go ahead and just assume you guys understand that this little slant actually means division. So when I get all this said and done, on the left side, I'm going to have x plus 5 all over 3 as if it was one big fraction. I'll write that right here, equals y. And then you have to go back and change that whole part again to equals f inverse of x. Okay, I got that pretty fast, right? Okay, so there's our inverse function. You can switch it around to the other side if you want, but there it is essentially. Now I need to get the table of values for our original function, which is 3x minus 5. So I'll go ahead and go to Desmos, and I'll go 3x minus 5, and I'll click up here in the little gear, get the table, and I have the values at -2. It's -11. At -1, it's -8. At 0, it's -5. 1, it's -2. 2 is 1. And I want the value for -3. So that's going to be a -14. You can just kind of tell Desmos what you want. And then I want the value also for +3, which would be like right here, so to speak. Oops, not 23. For 3, and I would get 4. All right, so why is this important? we're going to go back and fill in our values. Now, here in our table, we're asked to pick some x values and y values. I highly recommend whenever you're given the choice to pick 0 and the numbers right close to 0, because that's where usually most intercepts are happening, or interesting parts of graphs usually occur around the origin or so. So always try to use these standard values from -3 to +3 for these notes, especially for your x values. So I went ahead and got all my values from the Desmos table right now, and I have -3, -14, -2, -11, negative, let me get down to my little box here, -1, -8, 0 is -5, 1 comma -2, 2 comma 1, and then 3 comma 4. All right, so then there's my table of values right there. Now what I have to do is I have to go ahead and graph these ones. It says to graph the original function in green and the inverse in red. So here's my original function. Now I can go ahead and grab my little line here, and I'm going to go ahead and kind of adjust it. 3x minus 5, that means I have a y-intercept of -5, and I go up 3 over 1. Where was my x-intercept? That'll help me. So -5, and it looks like I have a x-intercept at about 1.667. So let's go ahead and kind of get this going. So it's going to be like something right here. -5 is down here. This line still has to be shifted over. 1.667. I'll kind of make this really a longer line. This is going to be very annoying to do by hand. You guys are lucky you have calculators or Desmos, and well, a pencil. I'd kill for a pencil right now to do this by hand. So it's going to be something like that. And then we have to do the inverse now. Well, the inverse points, if I have my original function points, the inverse is just switching the x's and the y's around. So actually, I could probably just delete all of this text dialog right here. Copy all my y boxes right here. Control copy, paste them into now my x column. And then I will take all my x values here. If I can just, so I can see if I can select them carefully. All these x values right here. And then I'll paste them into the y column right over here. So inverting points on a table is super easy, even by hand. You just switch your x and y values around. So now I have to graph the line x plus 5 over 3. Let's see what that looks like first of all. So let me go ahead and go back here, so I can get back to my actual graphing. Oh, I see what it's doing. It keeps going back to my previous calculations. Okay. So I had x plus 5 divided by 3. This would be such a faster video. I apologize had I not had to do everything digitally. So our line's going to go right here, and you zoom out a little bit on that. So this is kind of where my red line should be going. Has a, oh yeah, so the x and y intercepts basically just flipped. So whereas I had a line that went through -5 on the y-axis, now it's going to go through -5 on the x-axis, and then cross at, oh, excuse me, let me get this backwards. So my y-intercept, I have a point at -5, 0. So here's -5, 0. And then I have another point at, let's say, 4, 3, 4, 1, 2, something like this. So my line's pretty much this direction. So we can just stretch it out a little more now this way. Keeping it in line. So it's going to be like that. And then like that. All right, and look at, we get this nice, interesting little crisscross pattern going on here, which is not unintentional, you're going to see. So there's number 1 done for us. We have the inverse function right here, which I can go ahead and, for the sake of you guys' ease, I can highlight that. There's my inverse function. I have my table of values, the inverse table, which is just switching the points around, and then I graph the lines of both of these. And actually, I should highlight it maybe a little different. I should highlight this one because it's the red line. I'll highlight this in red to show what I'm really doing. And then I have this one up here, which is the original line, which would be the one in green. There. And that's how you represent over here on the graph. So let's try this process again for number 2. So I already went ahead and, switched out the f of x for y. Now I have to go ahead and do the whole process of switching out all the x's to y's. and all the y's to x's. So let's do that kind of quick. I hate that I'm not a touch typist, so I'm not really fast on typing on the keyboard and without having to look at it. I know, I'm horrible like that. So I have 3y plus 2 being divided by 4. I can't get to the top part of that fraction until I get rid of that denominator. The denominator means that everything's being divided by 4. So the opposite of dividing by 4 would be to multiply both sides by 4. So I'm going to go ahead and, I guess for the sake of switching out colors and stuff, let's do blue this time. I'm going to multiply times 4 on the right and multiply times 4 on the left by just putting the 4 in front of the x. When I do that, then I go ahead and drop down, switch back to my color. I have now 4x equals the stuff that's in the numerator, which is 3y plus 2. And now it's a two-step equation. I'm going to subtract 2 from both sides. So I'll go ahead and switch my color out again. I'm going to go minus 2 here, as well as minus 2 on the other side. When I do that, now I have 4x minus 2, which I wish would just come out automatically, but I know it's going to be difficult. There we go. So 4x minus 2 on the left side, and then I'm left with 3y on the right side. I'm going to have to divide both sides by 3, so I'll go ahead and put the left side in parentheses since I'm going to be dividing. I'll divide the left by 3, and I'll go ahead and divide the right-hand side by 3. I know, I'm just being anal with that color thing now, but I have to keep it going. All right, and so finally I get my final equation form of 4x minus 2 in the numerator, all being divided by 3. It would look like one big fraction if I had the capability and the time to do it right now, equals y. And then we go ahead and switch out that y to the function notation f inverse of x. All right, so this would be our original green line that we're going to graph right now. I might as well just highlight it right now. And this would be the red inverse function that we're going to also graph momentarily when we get to that point based on our table of values. So now I need to go and get some table of values. I'll go to Desmos. I'm going to enter the equation 3x plus 2, all being divided by 4. So I'll go ahead and take this out. In parentheses, I have 3x plus 2. Although I know you can do like a fraction bar on here, but this is just faster and it does it for me automatically. Anyways, 3x plus 2 being divided by 4. So let me go ahead and get a table of values for this really quick, and then I'll write them down, which I should have done in advance to make our lives a lot more interesting. But these points actually come out a little more, I have a lot of decimal pieces here. So what I think I'm going to do is just maybe write down the main points that are whole numbers so I can get them. Or maybe not. Okay, so negative 3 is negative 1.75. And I'll go ahead and start with negative 2 and all that like it was before. Negative 2 is negative 1. That's a whole number. And since I am dealing with, with decimals, but I am graphing straight lines still, it doesn't really matter if I have to write in decimal numbers and the grid's kind of small or whatever, because all you need are 2 good anchor points anyways, like I just found with 2 and 2. Let me figure out what 3 is really quick. 2.75 to make a straight line. So 2 good anchor points will totally help you get it, and it won't be a big deal. You'll see what I mean right now when I graph them again by hand. You, however, have the benefit of just getting like your ID and making a straight line between 2 points as well, and that should work pretty easy for you. So my anchor points are going to be at negative 2, 1. Oh, first of all, let me fill out my table. So let's get all this done, because I will need it right now for when I do the inverse. Negative 1.75. That's a little too squished up. There we go. And then I have, what here, negative 1, negative 1, and then the next box down, these in stupid decimals, negative 0.25 or negative 1/4. I have to expand this box some. And then at 0, I have 0.5 or half. At positive 1, I have a value of 1.25. Oh, that one fit, thank gosh. For 2, I have 2, an anchor point. Whole numbers are nice, easy anchor points. And then for 3, I get 2.75? Okie dokie. So there's all my x values, there's all my y values. And then I'm going to go ahead and invert them. So I'm going to take all the y values, Control copy, make those my x values. It's probably the only time in this whole lesson that I swear technology is a little faster. And then take all those and switch them to my y values. All right, so we inverted the table of values now, easy enough. So that should be pretty easy to make my points now. So let me go ahead and put part of this line at negative 2, 1. So let's see, negative 2, 1 would be negative 2, comma 1 right there. And another point at 2, 2. 2, 2 would be right here. So now let me go ahead and kind of just keep expanding on those lines, keeping this point going through 2, 2. And the line will keep going about that direction. And then keeping this other one going through negative 2, 1. I'll bring it out to about right there. See, so 2 good anchor points is all I needed. I used negative 2, 1 and 2, 2 to get that first line. Now I have to get the inverse over here, which is 4x minus 2 over 3. Let's see what that's going to look like on the same grid. So I'm going to put in parentheses 4x minus 2. All of that is being divided by 3. And I get a very similar line. And let's go ahead and graph it now. So I have opposite, I guess, anchor points for this one. I'm going to use negative 1, negative 2 as one of my anchor points. Negative 1, negative 2. Oops, I think I did something wrong. Yeah, in this first green one, I wonder if you guys even caught that. Negative 2, negative 1 is where I should have gone through, so that's right there. Okay, so I'll put that point right there. I have to redo my line now. My bad. That's what happens when I go too fast. All right, there we go. So expand this one through 2, 2. Let's see, till about right there. This one through 2, negative 1. So it's going to keep going till about right. Let's see. There. That's looking a little better. And then now to invert those points, I have one at negative 1, negative 2. So let's see, negative 1, negative 2 is down here. And then another point at 2, 2. Just like this, whoops, not hit the wrong part of my mouse. 2, 2, right here where that one goes. That's where they actually intersect. And let's go ahead and keep this line going. It goes through 2, 2 and keeps expanding. It's right there. This one goes through negative 1, negative 2, and expands right there. And once again, we get this nice, interesting kind of crisscross pattern, just like this one had above. Once again, not unintentional. Now let's go ahead and look at your second page. Now this one I'm actually going to leave for you guys to do. So 3 we're skipping because it has a graph called a hyperbola, which we haven't studied yet. I don't want to get into it just yet. So for number 4, what I want you to do is find the inverse function, at least do it algebraically, show me your work on your paper. Find the table of values using Desmos, fill in all your x's and y's as well as the inverses, and then graph your 2 lines also. You are going to get curves, and one's going to be a horseshoe curve, a quadratic, but the second one, when you, it's going to be a square root, because since we have squaring involved, we know our opposite function, or inverse function is going to have square root. You're only going to get part of the curve. That is on purpose. That is mathematically accurate. So don't freak out if you don't get a perfect sideways curve, and you'll see what I mean. So graph those to the best of your abilities on this grid, and then turn in these notes as proof of your work, either by the end of class or when you come into class tomorrow on Tuesday. All right, so best of luck, and I hope to see you guys, well, not hope, I will see you guys on Tuesday when I get back, all right? Have a good day, guys, and I'll see you later.